Bismillahirrahmanirrahim. Assalamu alaikum. So we have already seen that when h is equal to 1 by 4, this was the behavior x bar. It looked something like this. So it was converging from left, or stability from right and instability from left. So as the x values are getting smaller, the trajectories are moving towards the smaller values. So now coming back to the bifurcation diagram. Let me put h over here and x over here. So when h is equal to 1 by 4, then we have seen that, let me put this line, then we have seen that x equal to 0.5 is the equilibrium point, and the equilibrium point was approached from the right, the greater values like this, and trajectories or the flow was away from the point if the values are less than 0.5. Now talking about h to be less than 1 by 4, you can have lines. Let's say we have two lines. We had seen that in this case we had two equilibrium points. One was x star of left and the other was x star of right, and the other was x star of left, then x star of right, x star of left. So let me clear these points again. So these are equilibrium points. So like we have also seen that for h less than 1 by 4, the x star of left was source or unstable point, and x star of right was stable point. So in this case this is going to be stable, and this is going to be unstable. For h greater than 1 by 4, the flow would look like this. Now we can draw this. Is going to look like something like that. Very crazy drawing. Let me put this over here. So it would look like this. So what is happening when h is 1 by 4? We have one equilibrium solution, and if h is between 0 and 1 over 4, then we have two. One is stable and the other is unstable. When h is greater than 1 by 4, then we have no any equilibrium solution. So what I wanted to show you in this, let me show you clearly from the book. This is what we wanted to see. When h is 1 by 4, we have one equilibrium solution and is approached from the greater side and is repelled from the other side. And when h is between 0 and 1 over 4, there are two equilibrium solutions, and one is stable, greater one is stable, and the smaller one is unstable. When h is greater than 1 by 4, the equilibrium solutions are not there, so there is no point of discussing stability or instability. In fact, we can also discuss the graph in x prime plane. For h equal to 1 by 4, we had also seen that the parabola looked like this. for h equal to less than 1 by 4, it was having 2 equilibrium points. When h was equal to greater than 1 by 4, there are no equilibrium points, and the flow can also be constructed over here. So what is happening basically physically, or what is happening outside? So when h is between 1 over 4 and 0, in this rate of harvesting, if there is this kind of behavior, then population can persist, can defend, can survive despite the harvesting. This is why, because in this case we have two equilibrium solutions. One was x star of left source and x star of right, which is sink. So indeed x of 0, initial data or the initial population has to be greater than equal to this, so that the population may converge to this and remain resistant and long run. And when h is equal to 1 by 4, then a small change in harvesting, if h is small perturbed at 1 by 4, there is going to be a question of fate for the population, or there is going to be large change in the population. But when h is greater than 1 by 4, then population becomes extinct. At any rate of harvesting. Thank you. We can meet in the next video.